So now we'll start with your the next topic, that is your polysaccharide. Previous class, as I told you about your monosaccharide and oligosaccharide, and as I told you, monosaccharide and oligosaccharide, it is nothing but your oligosaccharide on hydrolysis. It is giving two or more than two or three monosaccharides. Okay, as I have shown you some of the examples also. Okay, maltose, your sucrose, all these. Okay, now we'll study with your polysaccharides. What is polysaccharides? Polysaccharides means upon hydrolysis they will give monosaccharides, they will give n number of monosaccharides. Okay, and we can say made up of more than 10 monomers units. You can say more than 10 monosaccharides units it will give on hydrolysis. Okay, and these polysaccharides otherwise known as your what, glycans. Okay, and these have no definite molecular weight, which these polysaccharides, these have no definite molecular weight, and enzymes are involved in the synthesis. Okay, these enzymes are involved in synthesis, and no specific stop points. Okay, no defined sequence or length. So these are the characteristics of your polysaccharides. And these polysaccharides are of two types. Okay, one is your homopolysaccharide and another one is your heteropolysaccharide. Okay, what is homopolysaccharide and what is heteropolysaccharide? What is homopolysaccharide? Homopolysaccharide, it contains single monomeric species, whereas heteropolysaccharide contains two or more kinds of monomeric units. Means, as I told you, it will contain your more than 10 monosaccharide. Okay, more than 10 monosaccharide. But if this 10 monosaccharide, suppose it is containing 10 monosaccharide, all 10 monosaccharides are glucose, then that is called homopolysaccharide, because all are having same nature, they are having same constitutions. That's why this is called your homopolysaccharide. Suppose these are containing 10 monomers. Okay, 10 monosaccharide it is containing. Okay, and all 10 are of different nature, like your one is glucose, one is fructose, one is your galactose. So all are of different nature. So that is called your heteropolysaccharide. Understood right now what is means homopolysaccharide and what is heteropolysaccharide? Okay, homopolysaccharide means all the monomeric units are of same nature, whereas heteropolysaccharide all the monomeric units are of different natures. Okay, and storage forms, how it is stored, these homopolysaccharide, these are stored mainly starch, glycogen in these form, homopolysaccharides. But and structural form mainly cellulose and chitin, and this heterosaccharide, it is providing your extracellular support for organisms of all kingdoms, all the classification, all organisms, for them extracellular support they are getting from heterosaccharides, heteropolysaccharides. Okay, like your glycosaminoglycans, as I told you, amino sugars will be there. This is a part of your cellular part. Okay, of your bacterial cell wall, as I told you. So like that, here also aminoglycans are there, glycosaminoglycans, peptidoglycans. So these will give you some extra support to the to the human, to the all the animal kingdoms, all the species. Okay, and homopolysaccharide, you can say these are stored from a form of your food. You can say starch, glycogen. Okay, all these are. Okay, so these are the two types, and this is the difference between these two. All of you clear all this, whatever I said? Now we'll see about your homopolysaccharide. One of the important homopolysaccharide, that is starch. Okay, so what is starch? This is the storage sugar in plant cells. In plant cell, the carbohydrate is stored in form of starch, homopolysaccharide. Okay, and intracellular large clusters of granules. Okay, how these are made up of? These are made up of your clusters of granules, and heavily hydrated. These are heavily hydrated, having more these are in hydrated form, and many exposed to hydroxyl groups. Okay, and storage as starch reduces intracellular osmotic pressures. Okay, it will reduce the intracellular osmotic pressures. Okay, and about starch also we'll see different properties, like your, as you can see, starch has two types of glucose polymer, amylose and amylopectin. Okay, this is having what? Starch has two types of glucose polymers. These are having what? As I told you, polysaccharide, it is formed from your what? It is formed from your what is that called? Different monosaccharides, and those different monosaccharides may be of mainly it may contains either maximum two different types of your monomers. But in case of your what, your what is that, hetero polysaccharide, in that case it is containing more than two different monomer units. Okay, so starch, it is containing mainly two parts. One is your amylose and another is your amylopectin. Okay, as you can see here, in these two forms it is available, two types of glucose polymer. One is amylose and amylopectin. The amylose mainly consisting of your long unbranched chain of D-glucose residue connected by alpha 1,4 linkage. As you can see, it is containing what, 1,4 linkage of your glucose, means different molecules of glucose, okay, with 1,4 linkage, as you can say. So that is called amylose, if it is containing all the molecules of your glucose. Okay, and amylopectin is a branch. The glucose residues are joined by your 1,4 and 1,6 linkage, but here the linkage is 1,4 linkage, but here means one glucose molecule is linked to or is linked to another glucose molecule of your 4th carbon atom. So that is called 1,4 linkage in your what is that called, amylose. And in amylopectin, same, the glucose linkage will be same in between, but here the linkage is between 1,4 and 1,6, as you can see here. Okay, so that is called amylopectin. Okay, and maximum how many residues will be there? 24 to 30 residues will be there, as you can see. Amylopectin or amylose, you can see 24 to 30 units of glucose will be there. So more than 10, as you can tell. So this is a homopolysaccharide. It is containing what? Same number, same monomers, means glucose it is containing, but numbers of more than 10. So that is why homopolysaccharide, or these are known as homopolysaccharide. Okay, now you can see this is the amylose. What is the structure of amylose? You can see this is the structure. Okay, on branch starch, and this is the amylopectin. As you can see, this is the branch starch. Okay, so this is called amylopectin. Okay, as you can see the structure, amylose. 1,4 linkage is there between 1 position and 4 position of 1, 2, 3, 4. So 4th position. This is the first position. So first 1 and 4 position, the linkage is there between in your different glucose molecules. That is amylose. Amylopectin, as you can see, 1 and 6 position, as you can see. Okay, this is the first position, and this is the position of your what? As you can see, 1, 2, 3, 4. Okay, 4 and 1, 6 also, as you can see. Okay, this is the one position, and also it is alternate, as you can see, 1, 2, 3, 4. 1, 4 linkage is there, 1, 6 linkage also there. Okay, as you can see. Okay, so 1, 2, 3, 4, 5, 6. 6 linkages is also there. So that is called amylopectin. Okay, as you can see all this. Now, so question will come. Amylose, starch can stay in two different homopolysaccharide form. What are those? My question. Starch can stay in two different homopolysaccharide form. What are those? Starch can stay in two different homopolysaccharide form. What are those? Are you listening, all of you? No answer up to now? I'm asking. Starch can stay in two different homopolysaccharide form. What are those? Okay, then tell me the answer. Tell me. Amylose and amylopectin. Okay. Tell me, amylose, what is the linkage present? And in amylopectin, what is the linkage? Okay, 1,4. Amylose, what is that? Alpha 1,4, alpha 1,4 and 1,6. Very good. So that is in amylopectin. Okay, then you will see glycogen, starch and glycogen, as I told you. Storage sugar in animal cells. It is stored in animal cell. In cell, there is starch. Okay, question will come. Which of the homopolysaccharide is the storage of sugar in plant. So starch. So which of the homopolysaccharide storing the sugar in animal cells? So your answer will be glycogen. Okay. And intracellularly large clusters of granules, as I told you, and it is heavily hydrated starch. Okay. Similar to amylopectin. Amylopectin means where the 4 and 1,6. So same. And difference, glycogen is extensively branched. It is very branched. Okay. That is only difference, as you can see here. This is your glycogen structure, as you can see. Alpha 1,6 bonding is there. Okay. So this is the only difference between these two. Okay. And the branch point occurs every 8 to 12 residues. Okay. The branch point occurs every, this whatever the branch is forming. Na? So every 8 to 12 residues, after 8 to 12 residues, it will be happened. Okay. So has one reducing end and many non-reducing end. This glycogen is having one reducing end and many non-reducing end. And this is found in the liver, constitutes as much 7% of weight. Okay. So it is mainly found in liver, this glycogen. Okay. It is stored in form of sugar. It is stored. So that is called your, in your liver it is available, and it is mainly 7% of weight of. Okay, and also present in skeletal muscle also. In skeletal muscle also, this glycogen is also available. Okay, now we'll see what are the different qualitative tests for carbohydrates. Okay, what are the different tests? What qualitative test means how to find out the presence of carbohydrate, how to know the presence of carbohydrate. Okay, so different tests are carried out there. So monosaccharides of biological significance, as you can say, what are the importance of those? Triose, what is that? Dihydroxyacetone. Okay, aldose and ketose means triose means 3 carbon containing your carbohydrate. In aldose form, this is glycerose. In ketose form, it is dihydroxyacetone. Tetrose, 4 carbon containing carbohydrate. Either it may be available in erythrose. If it is aldose, it is erythrose, and if it is ketose, erythrulose. Okay. And in pentose form, if it is aldose, then ribose, arabinose, xylose. And if it is in ketose form, then it will be ribulose. What is the difference we are getting? So erythrose, erythrulose, ribose, ribulose, xylose, xylulose. So question will come. Xylulose is which of the form of carbohydrate, aldose or ketose? So it will be ketose, xylulose. Okay. Similarly, hexose, you can see glucose, galactose, mannose. Okay. But ketose is your fructose. So here only ketone group is present. Here your aldehyde group is present. This is heptose. Okay, heptose means 7 carbon containing aldose. It is not there on anything. So pseudoheptose, heptulose. Okay. So this is about your monosaccharides of biological importance. Disaccharides of biological significance, which are mainly by your having any biological importance. You can see isomaltose. Okay, this is mainly enzyme hydrolysis of starch. Okay, this is enzymic hydrolysis of starch. Starch on hydrolysis it will give. Okay, it's an enzyme isomaltose. Maltose, enzymic hydrolysis of starch. Amylase when it is hydrolyzed, it is giving maltose. Okay, and germinating cereals and malt, it is available. Lactose is available in milk also, milk products. You can see many pharmaceutical preparation as filler. Okay, sucrose, it is available in cane and beet sugar. Okay, so lactose, it is very important. Milk, it is available. Sucrose, it is available in cane sugar. Okay, polysaccharides of importance. Homopolysaccharide, as I told you, starch, glycogen. Okay, starch is available in your plant cell. Glycogen is stored carbohydrate. It is available in animal cell. Okay, and starch also, as I told you, this alpha, what is that? Amylose and amylopectin. Okay, as I have shown you. And as you can see, fructosan and galactosan. This is glucosan. It is produced from glucose. If it is produced from fructose, that is called inulin. Okay, if it is produced from galactose molecule, then it is called agar. Okay, you have to remember. So agar is a homopolysaccharide. Question: agar is a homopolysaccharide made from which of the carbohydrate? Monomeric form. So answer is your glucose, fructose, galactose. Answer is which one? Anybody? Agar is a homopolysaccharide made from glucose, fructose, galactose. Tell me. Glucose. See clearly. Agar. Agar is formed from which of the monomeric monosaccharide? Galactose. Okay. You are saying glucose? No. Galactose. Very good. Now, so heteropolysaccharide, as you can say, non-sulfated means without sulfur. What is that? Hyaluronic acid. Okay. Chondroitin. And sulfated, keratin sulfate. Okay. Neutral polysaccharide, blood group substances. Okay. So these are called your heteropolysaccharides. Okay. Then we will see qualitative test for carbohydrates. As I told you, what are the different tests we are doing to find out the presence of carbohydrate. Okay. Like as I told you, preliminary procedures. Okay. Different first procedure. What is that? Obtain an unknown carbohydrate. Take one carbohydrate. Prepare 1% solution. 1% solution, how to prepare? 1 gram of carbohydrate you take, then make up to 100 ml with water. Add 100 ml of water. By dissolving how much? 0.25 gram of carbohydrate. Okay. 25 ml of deionized water or 1 gram in 100 ml. Okay. Principle, what is the principle? First test is your Mollis test. Different tests we are carrying out. What are the different tests? Mollis test, Barfoed test, Bendix test. Okay. All this. So Mollis test, why it is called? Because it is using one reagent, that is Mollis reagent. Okay, in this case what we are doing? So carbohydrates when treated with concentrated sulfuric acid undergo dehydration. Okay, so when we are reacting with your treating with your sulfuric acid, what is happening? Dehydration process is going on. Dehydration means what? Water molecules will be lost. So when water molecule will be lost from the carbohydrate, what they will form? They will form furfural derivatives. And these compounds condense with alpha naphthol to form colored products. Okay. Pentose generally yield furfural while hexose yield 5-hydroxymethyl furfural. Okay. What is the main thing? What is the Mollis reagent? Mollis reagent is nothing but alpha naphthol with your sulfuric acid. Treating the carbohydrate with alpha naphthol with your sulfuric acid. So composition of Mollis reagent, they will ask. What is the composition? Sulfuric acid and your alpha naphthol. Okay. So when we will react any pentose means like your fructose. We will react with your fructose, we will get one furfuran. But while we will react with your hexose means glucose, suppose we will get 5-hydroxymethyl furfuran. Okay. 5-hydroxymethyl. Okay. Everywhere we will get furfuran. But in case of hexose, we will get 5-hydroxymethyl furfuran. Got all of you my point? Okay. And this is a sensitive but non-specific test and is given by positive by all types of carbohydrates. All the carbohydrate tests, they are giving all these tests, positive tests. Okay. And oligosaccharides and polysaccharides are present. They are first hydrolyzed to monosaccharides, which are then dehydrated to give the test positive. Okay. If you want to do the test for any oligosaccharide and polysaccharide, then what you have to do? First you have to convert it into your monosaccharide, then that monosaccharide you have to react with your Mollis reagent to give any your furfural or 5-hydroxymethyl furfural. Got my point? This is the difference between this one. Okay, so this is a basic test for what? Monosaccharide. Which one? Your Mollis test. Okay, then Bendix test, what is that? Carbohydrates with free aldehyde or ketone groups have the ability to reduce solution of various metallic ions. So what is the main principle behind that? Carbohydrate, those who are having free aldehyde group or ketone group, they are having the ability and they may react as a reducing agent. For what? For different metallic ions. They may reduce some metallic ions. Okay. Like your reducing sugars under alkaline conditions tautomerize and form N-diols. Okay. This is main the principle behind that. So whatever reducing sugars are there, they will under alkaline condition means in presence of any base, they will tautomerize. Tautomerize means keto form to enol form. So there will be change from keto form to enol form or enol form to keto form. Okay. So N-diols are powerful reducing agent. Okay, this N-diols, whatever it is formed right now, these tautomers, these are powerful reducing agent. And to whom they will reduce? They will reduce some of the metal ions, as I told you. Like your cupric ion, they will reduce to cuprous form. Okay, as I said you, what is the principle behind this basic Bendix test? In Bendix test, what is happening? They are having some free aldehyde or ketone group. So when it will react with your any metallic compound, they will reduce that metallic compound to your reduced form. Like your cupric ion, they will convert to your Q plus form. What is the reason behind that? What is the mechanism behind that? Mechanism is that when alkaline condition is applied, they will be converted to tautomers. Tautomers means either keto form or enol form. Okay, and this is called your N-diols. Okay, this N-diols is acting as a reducing agent that will reduce the cupric ion to the cuprous ion. Okay, so question will come in Bendix test. What is the reducing agent? Which element or which compound is acting as a reducing agent? Can anybody tell me? In Bendix test, which compound or which intermediate is acting as a reducing agent? Can anybody? No answer. You see, answer. No, no carbohydrates. Tell me which intermediate. I have asked you the question. Cupric ion will be reduced. Cupric ion is not a reducing agent. Here, which element, which intermediate? You just listen the question carefully. In Bendix test, which intermediate will act as a reducing agent? Got my point? Which one? Yes, very good. N-diols. Sarda, you are absolutely correct. N-diols. That is a tautomeric form. Intermediate. So Bendix test, as you can see here, 5 ml of Bendix reagent we are taking. Okay. Then 8 drops of carbohydrate solution. Okay. Then boil over the flame or in a boiling water bath for 2 minutes and let the solution cool down. So this is the negative reaction. If it will show positive reaction with your Bendix reagent, then it may form this type of powder. Okay, interpretations as I told you, Bendix test is a semi-quantitative test. The color of the precipitate gives raw estimating of reduced present in the sample. So this is a test. This Bendix test, it is meant for you reducing sugar. Okay, and green color it is obtained means what where we can say it is containing 0.5% of glucose. If green precipitate is formed, we can say 0.5 to 1% glucose is formed. If yellow precipitate is formed, we can say 1 to 1.5% of glucose is there. If orange precipitate is there, 1.5 to 2% of glucose is there. Okay. If brick red precipitate is there, we can say more than 2% of glucose is there. So glucose is confirmed. If red precipitate is formed, then you can say glucose is present. Okay. And all these tests telling that how much of the glucose is present, how much of percentage of glucose is present. Got my point? So this is about your Bendix test. You want to write all this? Then I'll wait. Otherwise, I'll go to the next slide. You want to write? This is very important. Question will come. The presence of green color by Bendix test. Presence of green color by Bendix test confirms the presence of glucose in what quantity, on what percentage. So you can say up to 0.5% of glucose. Okay. All have you written this one? Okay. Next I'll go for the Bendix test as I told you. So this is your Bendix test as I showed. Okay, overall. So this is a test for your reducing sugar. Then Barfoed's test. Okay. What is Barfoed's test principle? Aldols and ketones can reduce cupric ions even in acidic conditions. That was in your Bendix reagent. It was in your basic conditions. But this Barfoed test, it is in your acidic conditions. Okay, in presence of any acids. The test is used to distinguish reducing monosaccharides from disaccharides. Okay, this is a test to carry out to differentiate between a reducing monosaccharide from disaccharides. Okay, by controlling the pH and time of heating. And monosaccharides react very fast, whereas disaccharides react very slow. So that it will be confirmed. If disaccharide will be there, means they will react very slowly. But monosaccharide will be there, means they will react very fast with Barford reagent. Okay, as you can see, 2 ml of Barford's reagent, 2 ml of carbohydrate solution is there. Okay, carbohydrate solution means how much? That 1% solution, whatever we have prepared initially, 1 gram in 100 ml. And keep the test tube in the boiling water bath for 3 minutes. We have to keep this one on your bath for 3 minutes. Okay, cool under running water. Okay, we have to cool it. Overheating should be avoided. We should not have to heat for more time. Okay, the positive reaction indicates the presence of reducing. On prolonged heating, disaccharides can also give the taste positive. So you have to avoid the prolonged heating. Okay, hence the solution should be boiled for 3 minutes only. Barford test is meant for heating the sample for 2 minutes only, 3 minutes only. Okay, so what you have to take? 2 ml of carbohydrate solution you have to take, add 2 ml of Barford reagent, then you will get like this. The red precipitate will be there. A scanty brick red precipitate is observed in a positive reaction. In positive reaction, you will get this type of color. A precipitate will be formed at the bottom. So this is called your Barford reagent. Okay, and this is meant for differentiating between monosaccharide and disaccharide. Monosaccharide, as I told you, it will react very fastly. If monosaccharide will be present, the color will be changed between 3 minutes. Precipitate will be formed between 3 minutes. Okay, and if monosaccharide is not present, means red precipitate will not be formed. Okay, if red precipitate is going to be formed after 3 minutes or upon prolonged heating, then you can say disaccharide is present. Got my point? All of you? All of you got what I said? Clear or not? Okay. Now we'll see one of test. But it is also one of the major tests for that. Ketohexose. Okay, mainly ketohexose on treatment with hydrochloric acid, like the fructose. This is a test for fructose. Ketohexose. Okay. Ketoaldose means glucose. Aldohexose means that is glucose. This is ketohexose. Ketohexose means it's a fructose. On treatment with your hydrochloric acid, form 5-hydroxymethyl furfuran. Okay, which on condensation with resorcinol give a cherry red color complex. This is your what is that? Okay, what is the we are reacting with hydrochloric acid. Okay, so that 5-hydroxymethyl furfuran will be formed, and with resorcinol. Resorcinol is part of Selivanov test. So in that case, cherry red color complex will be formed, as you can see here. Okay, as you can see procedure: 3 ml of Selivanov reagent, 1 ml of fructose, boil for 30 seconds. Okay, cool the solution. So what will happen? A cherry color is observed in a positive reaction. This is a negative reaction. So positive reaction. So one cherry red color will be formed. Okay. Then Selivanov test, as I told you, interpretation. What is that? The test is mainly for your ketohexose. Okay, and this test distinguishes between glucose and fructose, means aldose and ketose. It will differentiate between that. Aldose will not show this test. Okay, and overheating of the solution should be avoided. We should have to avoid always overheating. Upon continuous boiling, aldose get converted to ketose and give a positive reaction. So we have to avoid. If glucose is there, it will show negative result. If you heat for more time, it may show the positive result. Then you can say that is the glucose only present. Got my point? Next. Hydrolysis test for sucrose. What is the hydrolysis test for sucrose? Sucrose on hydrolysis with hydrochloric acid converted to glucose and fructose, as I told you. And the presence of these two monosaccharides can be confirmed by Bendix and Selivanov tests. Okay, Selivanov test, as I told you, these are the two tests which can differentiate your monosaccharide, which can differentiate from aldose to ketose. Okay. Then high test for sucrose, as you can see, HCl you have to take, thymol blue you have to take, 5 ml of sucrose solution, pink color will be developed, indicate it is acidic, solution is acidic. Then divide into 2 equal parts. After that you have to divide into 2 equal parts. What you have to do, understood my point? You have to take 5 ml of sucrose solution. To that you have to add 2 drops of HCl and 1 drop of thymol blue. Okay. Then you will get a pink color. So whenever you will get a pink color, you should be confirmed that it is in acidic conditions. Okay. Then what you have to do? You have to divide into two parts, two equal parts. One part you have to boil with for 1 minute, then you have to cool under tap water. Then another part and neutralize both portions by adding 2% of sodium carbonate drop by drop. Then one part you have to boil and another part you should not have to boil. One part whatever you have boiled right now, you have to cool it under tap water. Then what you have to do, both the parts you have to neutralize because already it is acidic, na? So you have to neutralize with what? With one basic substance. So 2% sodium carbonate solution you have to take and you have to add drop by drop. So what you can see formation of blue color indicates neutralization. So blue color if it is obtained, then it is telling that neutralization. Then perform the Bendix and Sullivan's test with the boiled portions. Okay, with the boiled portion you have to perform the Bendix and Sullivan's reagent. So what will happen? The boiled portion gives positive test with Bendix reagent, but unboiled portion doesn't reduce Bendix. Okay, this is the difference. How you can difference between your this one, aldos and ketos. Okay, suppose how you can differentiate. Okay, then Osazone test. What is Osazone test? Osazone test is nothing but it is meant for reducing sugar. When reducing sugar are heated, then with phenyl hydrazine. Okay, with phenyl hydrazine, characteristic yellow crystalline compound will be formed. That is called Osazone. Okay, and these crystals have definite crystalline structure, precipitation time, and melting point for different reducing sugar. So that is called Osazone test. So you have to react with what? Phenyl hydrazine reagent. Okay. As you can see, 10 drops of glacial acetic acid, 5 ml sugar solution you have to take. Then you have to add how the test is performed. 5 ml of sugar solution, 10 drops of glacial acetic acid. Then you have to add phenyl hydrazine hydrochloride. Then double the amount of sodium acetate crystals. Okay. Then mix and warm a little to see the solids are dissolved on. After that, filter the solution to another test tube. Then filtrate whatever you have got right now. You have to boil for 20 minutes on water bath. Then allow that boiling portion to cool down under tap water to have better crystals. Then examine the crystals under microscope. Okay, you will see these type of structures. Glucazone crystals under microscope, as you can see, needle shaped or rhombic shaped. This is rhombic shaped. This is sunflower shaped, as you can see, and this is powdered form. So these type of things you can observe under microscope. Understood what you have to do? First of all, what you have to do, as I told you, you have to take 5 ml of sugar solution, 10 drops of glacial acetic acid. To that you have to add phenyl hydrazine, then double amount sodium acetate crystals. Then you have to warm. Okay, after warming we have to filter it. Okay, then what you have to do, you have to cool it. Okay, then what you have to do to that tube, you have to add, means you have to make it cool so that more crystals will be formed. When the crystals will be formed, you have to observe under microscope so that you can observe these type of crystals. Okay, so this is about your Osazone test. Okay, so as you can say, glucose, fructose and mannose produce the same Osazone because of the similarities in their molecular structure. So glucose, fructose and mannose, they will form same crystal structure. Galactosazone crystals are formed in 7 minutes. Maltosazone crystals are formed in 10 to 15 minutes. If you take galactose and you will get the crystal within 7 minutes, and if you take maltose solution and you perform the experiment, you will get 10 to 15 minutes to have the crystals. Okay. Next is your Bial's test. What is Bial's test? Bial's test is nothing but the test reagent dehydrates pentose to form furfuran. Dehydrates means water molecule will be lost. Okay, water molecule will be lost to form one furfuran. Okay, this is the main test reagent. This test, by using this reagent, your dehydration process will be there to form a furfuran. And that furfuran, whatever right now formed, that will be reacting with your orsinol, one reagent, and iron. Orsinol and iron in iron presence. So what will happen? It will form a bluish product. So you can say Bial test is passed. Okay, and the solution is then heated gently on Bunsen boiler and or hot water bath. Okay, so as you can see here, the reaction. This is the bile test. The bile test, what are the reagent we are taking? Can anybody tell me? In bile test, what reagent we are taking? Tell me. Everybody listening? In bile test, which reagent we are taking? Bile test, which reagent we are taking? No answer. That means you are not listening. No. Resorcinol. Resorcinol. Okay, resorcinol. And one more thing, what we are doing? Ferric chloride, Cl, all this. Orcinol. So that is called bile test. Okay, as you can see. Okay, then iodine test. Iodine forms a coordinate complex. When iodine solution you have to take and you have to add to the this one. What is that? Sugar solution. So what will happen? You can see here, left to right. Lugol's iodine. This is starch iodine. Starch solution with iodine. This is starch solution. If you only starch will show the reaction to that. Okay, only Homo polysaccharide. This is meant for only Homo polysaccharide, and this is a confirmatory test for starch. Question will come. Which of the following test is confirmation test for presence of starch? So iodine test. Iodine test is the confirmation test for starch. Okay. If it will show this type of your violet color solution immediately with your iodine solution, then you can say presence of starch is there. Okay. Other compounds it won't show any violet color formation. Okay. Now summary, as I told you, Mollis test. For glucose it is positive, fructose it is positive, maltose, all the sugars it is positive, Mollis test. Bendix reagent, Bendix test. For sucrose it is coming negative, for other it is positive. So this is a confirmation test. If you will take sucrose solution Bendix test, it will show negative result. It will not show, you will not get the result. Then you can say presence of sucrose is there. This is a very confirmation test for sucrose. Barfoed test, similarly, it will show positive for all the things. For negative, it will show negative result for maltose, lactose, and sucrose. These won't show the test for Barfoed test. Okay, and as I told, Selivanov test. Selivanov test will show for the fructose only. As I told, it is the test to differentiate between the ketose and your aldose. Okay, thus this is Selivanov is meant for your ketose. Okay, it is not meant for your glucose, aldose. Okay, now as you can see, inversion, for inversion test it is positive for only sucrose. So for sucrose, one more confirmation test is there, inversion test. Okay, Osazone test, what is that? Osazone test, it will come negative for sucrose, for other it will show the cells, it will show some crystals. For sucrose there will be no formation of crystals.